Hey, kiddos! Let us continue our journey into the world of trigonometry with sine, cosine, and tangent. This is all basically a review of SOHCAHTOA. Okay, so all trig functions are used for right triangles only. Each one is a proportion, and when working the problem, you should cross multiply to solve. And that's when we actually get into setting up problems. Okay, so remember, very important about SOHCAHTOA is that for sine, you're looking at opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent is opposite over adjacent. Next thing is always to make sure that our calculator is set to the degree mode. So here's just a little review on how to do that and make sure, okay? So very important, whenever we're dealing with trig, we want to be in degree mode. Any other time that we use our calculator, it needs to be in radian mode. But for trig, has to be in this mode. All right, so first example, we're going to look for the value of x, and we're using our trig here. All right, so for the first problem, notice I have marked what my theta is. That's the degree, okay? So theta is 21. So notice it's really going to be, when we set up our equations, it's sine or cosine or tangent of theta, whatever that degree is, equal to whether it be opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. All depends on what we're doing. Now, the reason why we're using sine, because based on my theta location, we have an opposite and we have the hypotenuse. So because I have opposite and hypotenuse, then I'm going to use sine. Now, it is going to be sine of 21 degrees equal to opposite, which is x, over h, which is my hypotenuse, which is 12. So here's where the math part works. This is where we're going to solve. So basically, we would be, in a sense, cross multiplying, solving for x type of business. So if I cross multiply, I get 12 times the sine of 21 equals to 1 times x, which is just x, and that's what we need. So to do the rest of this, you have to have a handy-dandy calculator, okay? So I know some of you at home have these fancy calculators, so you should be able to be good to go in doing this. For those of you who don't have the fancy calculators, then at minimum, you need to at least get to this point on any problem that I have you guys do on your own. So that way, when you come to class, you can quickly, I'll give you a few minutes to grab your calculator and actually finish out solving those. And all you're doing is just putting it into a calculator. You shouldn't actually be working out anything on hand. So on my calculator, we go 12 times the sine of 21. And when we multiply that, if you end up with a decimal answer, that's okay. Let's just round to the nearest tenth. We end up with 4.3004. So 4.3 is our x value. So again, the reason why we're using sine here for this problem is because we're given the opposite and the hypotenuse. So next problem, identify my theta, which is the 59 degrees. Based on my theta, I'm given the opposite and the hypotenuse. So that again is why we're using sine. So it's very important that you guys recognize what you're given to help determine whether you're using sine, cosine, or tangent. So sine of 59 degrees is equal to opposite, which is x, over 17. So if I cross multiply here, we end up with 17 times the sine of 59 degrees equals to 1 times x, which is x. So when I work this out in my calculator and I do 17 times the sine of 59, we get an answer of 14.571, so 14.6 equals our x value. All right, so next example here. Now the question is, why are we using cosine? So let's see, based off our location of theta, which I've already marked here where my theta is, we have the hypotenuse, and we also have the side that is touching our theta, which makes that the adjacent. So why are we using cosine? We're using cosine because we have the adjacent side and the hypotenuse, and that's cosine. So to work this out, we have cosine of 42 degrees equal to adjacent, which is 20, over the hypotenuse, which is x. So when we cross multiply here, and I'm going to show you guys the proper mathematical way and then tell you what the shortcut is, okay? So if we cross multiply, we would have x times the cosine of 42 degrees equals to 1 times 20, which is 20. We're solving for x here, so I'm going to, since that's being multiplied, I need to do the opposite and divide both sides by the cosine of 42, so that cancels out. So our x is going to be equal to 20 divided by cosine of 42. If you paid attention to that music video that I showed you guys, they actually talk about this in there. So really, anytime you have the x, the unknown, is in the denominator of our fraction, all you really have to do is just switch the location of the sine, cosine, tangent, whatever it is, into the bottom when solving, essentially. So you just switch their locations, and that's how you would solve. Okay, if x is at the top, then you're just doing basic cross multiplication. You just multiply. Okay, so food for thought. So let's actually work that out. 20 divided by cosine, so make sure you use cosine instead, of 42 is a answer of 26.91. So we'll say it's 26.9 would be our answer for that first problem. Now for the second one, cosine, first identify my theta, which is here, it's 51 degrees. So let's see, would we really use cosine? That is the hypotenuse, and based on my theta of 51 degrees, that is the adjacent. So yes, because I have adjacent hypotenuse, we're going to use cosine. So cosine of 51 is equal to adjacent, which is 10, over hypotenuse, which is x. So again, remember that shortcut. Basically, to solve for x, we just switch its location with cosine of 51. Right? So that's the shortcut there. Or if you don't trust the shortcut, you can still do this, and it'll come out to the exact same thing. Okay? So, handy dandy calculator now. 10 divided by cosine of 51 is equivalent to our x being 15.89, which is going to round to 15.9. All right, so here's our next example. So again, let's identify our theta. So in this case, it's right here where 63 degrees is. And now let's label our sides. I have the opposite side and I have the adjacent side. So why are we using tangent? Because we have the opposite and the adjacent side. So tangent of 63 equals opposite, which is x, over adjacent, which is 8. We're going to cross multiply, so you get 8 times the tangent of 63 is equal to 1 times x, which is x. So 8 times tangent of 63 gives us a total of 15.7. All right. Time for y'all to do that one on your own. All right, so now let's say we're looking for an angle. Now, so that means we have the sides, but we're not sure what our theta is. So we're looking for theta. When that occurs, then we have to use something called the inverse. So the inverse trig ratios And that's a feature that we have in our calculators, is written with the -1. Okay, and like I said, that is a feature on your calculator, so you should be able to see it where sine, cosine, and where the actual buttons are in a different color. The calculators that we use at school, it's in blue. It says sine of raised to the -1 degree, cosine raised to the -1 degree, tangent raised to the -1 degree. We only use those functions when we're looking for the actual angle. Okay, so tangent, remember, tangent is still adjacent. Sorry, it is opposite over adjacent. So essentially, it would be tan to the -1 degree equals the opposite over the adjacent. For sine, it would be sine to the -1 degree is equal to opposite over hypotenuse. And hopefully we recall that cosine would be of raised to the -1 power would be adjacent over hypotenuse. Like I said again, these are functions that we will have in our calculator, and we only use these when we're looking for the actual angle. So we don't know what the angle is, okay, and we're wanting to know what is that degree, that's what we would use. Now, the proper way of reading tangent to the -1 power x is actually saying the inverse tangent of x, okay? So this is the inverse tangent is how we're going to refer to whenever we see tangent raised to the -1 power, okay? So if we hear the inverse tangent, that's what it means. All right, so here we're going to do a few examples. Let angle A, angle B, and angle C be acute angles. We're going to use a calculator to approximate the measures of those three angles to the nearest tenth of a degree. So yes, you need a calculator for this section. Again, make sure your mode is in degree mode. And what we have here is, so for the first one, tangent of A equals 3.29. So remember, since we're looking for an angle, we're using the inverse of tangent, okay? So in my calculator, I'm going to hit second tangent, then I'm going to type 3.29, close the parentheses, enter, and I get 73.1 degrees. Now B, sine of B equals 0.55. Sine of B, I'm looking for the angle, okay? So that means I'm using the inverse of sine this time. So second sine, 0.55, hit enter, and I get 33.4 degrees. And next you have cosine of C equals 0.87. Looking for the measurement of the angle C, so therefore we're using inverse of cosine. So when I type that in, we get 29.5 degrees. All right, so for the next example, solving a right triangle, first thing we need to find is the measurement of side AB. The nice thing is we know this is a right triangle, so we know we can use Pythagorean theorem because we're given two sides. So let's go ahead and use Pythagorean theorem here. So we have 3 squared plus 2 squared equals c squared. That's 9 plus 4 equals c squared. 9 plus 4 is 13, and then I have to take the square root of 13 to get c by itself, and you end up with 3.6 if we're going to round to the nearest tenth. So that is 3.6. Now to find the measurement of angle A. So it's always safest, because let's say we made a mistake, so we don't want to really use that. It's always safest to use the values that are already given to you. So I'm going to use these two sides, which based on theta of measurement A, so based on theta being angle A, I have the opposite side and the adjacent side, which means I'm using tangent. Now remember, because I'm looking for an angle, I'm using the inverse of tangent. So it'll look like this. And then my values is opposite over adjacent, which is 3/2. So my calculator, when I use inverse of tangent, 3 divided by 2, we get a measurement of 56.3 degrees. All right, now to find the measurement of B, so let me change this. So B is here. So this is no longer correct because now we're looking at B. So across from B is the opposite, and what's next to it is adjacent. So it's still going to be the tangent, or the inverse of tangent, since we're looking for the angle, but this time it's 2/3. So when I put that in my calculator, remember, make sure you're using the inverse function of tangent, because we're looking for an angle of 2/3. We get 33.7 is what it would round to. All right, next problem, we have XZ is what we're looking for first. So where is it? XZ. So it's this value here that I'm looking for. So let's see what we have here. Let's say I know this is 41 degrees, so there's my theta. Based on my theta, I have this is the opposite. That is adjacent. And that is my hypotenuse. Now, it does me no good to use opposite and adjacent because those are two values that I don't know. That's x, that's y, so they don't even tell me. So I have to use something with the hypotenuse. So to figure out xz first, I'm going to use adjacent over hypotenuse, which is cosine. So cosine of 41 degrees, notice I'm not using inverse here because I'm not looking for the angle. So cosine of 41 degrees equals adjacent over hypotenuse. All right. So we're going to cross multiply. So we have 18.4 times the cosine of 41 is going to be equal to our y value. And when I put that in my calculator, 18.4 times cosine of 41 degrees, we end up with a side measurement of 13.9. Now to find the next one, which is zy. Okay, so based on looking for zy, that means I'm going to use the opposite over hypotenuse. So that means that is, yes, sine. So sine now of 41 degrees is equal to opposite, which is x, over hypotenuse, which is 18.4. Cross multiply, so 18.4 times sine of 41 equals x. And when we do that in our calculator, 18.4 times sine of 41 degrees, we end up with 12.1. And now we're looking for the measurement of angle y. Technically, you don't have to use the inverse function here because hopefully you guys recall that the three angles inside of a triangle add up to 180 degrees. So therefore, if you know that these are, this one is 90 and this is 41, I simply just have to add those and then subtract that value from 180, and you end up with measurement of y having to be 49 degrees. All right, awesome sauce. That's all, kiddos.